Welcome to this episode of the NewSpace India podcast, a show to keep you informed and engaged on India's space activities. The roadmap for Indian space activities today is very mature, with the Indian Space Research Organization having a blueprint for the next 20 or 30 years. However, how was it when it all started and the roadmaps were not as clear as today? Today we have Chandrashekar, who is a visiting chair professor at the National Institute of Advanced Studies in Bangalore, to speak about his time in the Indian Space Research Organization starting from the mid-70s until the mid-90s. He has covered all parts of this program, including satellites, rockets, as well as applications of space technology, especially in remote sensing. He is also involved in activities relating to international cooperation and has represented and led Indian delegations to the United Nations Committee on Peaceful Uses of Outer Space. Welcome to this episode of the NewSpace India podcast.
Thank you very much for having me here.
You've had a very long career in ISRO and you were also involved in its very early days. So it's really interesting to know your perspective of ISRO and space in India. To begin with, I wanted to have a discussion with you on, the motivation to get into space and so on. From what I understand, the early days of space in India were really space science focused, where Professor Sarabhai himself, being a space scientist, probably had the motivation to go more science rather than space applications. And therefore, the physical research laboratory was driving a lot of this. And any kind of technology that was developed was potentially, in support of space science and not really application. Is this right? And why is it that, we didn't potentially start directly with space applications in India?
I think Sarabhai, it is not totally correct to say that Sarabhai focused only on space science. It so happened that he was a space scientist and he saw the potential of space and the developments in space. And it is also logical that since he was very well connected with the scientific world, his original research involved the use of space in order to further science, which was really the motivation with which he started. But fairly early on, he was fairly clear that India needed to do much more with respect to what is possible in space. I don't know whether many people know, but Sarabhai was not only a guy who looked at the potential of communication satellites and what it could do from space, he was also one of the pioneers of looking at possibilities of what remote sensing could do. And in the 1968 conference on space, of which he was the chairman, NewSpace India, and he was the chairman, he actually made this profound intervention where he actually talked about the potential of remote sensing, which was still, largely in the future. Okay. So he had a view and he saw the route to that view initially through a way to justify the creation of capabilities in the country. And obviously, because of the location of the geomagnetic equator, Tumba, and PRL's credentials earlier, he saw this as an easy route or one route in order to be able to establish the program in the country. So to me, he had a view of the totality of what he wanted, and this was one step in that totality. Okay, so that I think is a more fair description.
And was the Tumba Research Laboratory, where they wanted to do all this geomagnetic science and so on, was this, very well thought out, or is this something that is more opportunistic in a sense, where, it happened that there were countries that were trying to collaborate with India or, compete with each other in a sense? And how did this whole thing evolve to be, to have India at the center of all of this?
See, in order to do the location is all important. Okay. So Tumba happens to be located favorably for studies at that time. And sounding rockets were obviously the way to sound the atmosphere to figure out what was happening, so that one understood the physics of the problem or the science of the problem, if you want to use them. So it was therefore a favorable location. Globally, it was one of the few locations where it did matter. Okay. So that was an Indian advantage. But I would tend to believe that Sarabhai, while he was a scientist and saw this opportunity, he definitely also had in mind the fact that he saw, bigger rockets. He didn't see sounding rockets, which are really If you look at it technologically, they're relatively primitive when you compare it to the launcher. And the payloads that we put up in those days were relatively simpler payloads when you compare it with other payloads today. So, but I would tend to believe, based on whatever I've read of his writings and all that, he had this view that space for a country like India was very, very important. Maybe his thinking evolved as he got involved in it, and maybe he saw that possibility. And he was, of course, in a very favorable position because he was very well connected with the political system. He was also the chairman of the Department of Atomic Energy at that time. So he had all the necessary political linkages also to enable this nascent effort to actually take fruit. Yeah.
In that sense, when the focus really shifted from space science towards space applications or developing solutions to solve some socio-economic problems in India, what was the nature of the people who were involved, who were really involved in the sense of scientists or sociologists or so on?
See, my point is Sarabhai himself had thought about a lot of these things before Professor Dhawan took over. Okay. And I've had many exchanges with Professor Dhawan when I was working with him. And he always told me that Sarabhai, or Vikram as he used to call him, understood a lot of what he had in mind. Clearly, communication satellites and the notion of using satellite TV for education was very, very big in the agenda at that time. And Sarabhai's connections with the world were such that the SITE experiment, which was actually, in my opinion, possibly the first experiment of its kind at the scale in those days, which actually looked at trying to transform, rural India, right, in terms of TV-based education, was something that he managed to convince NASA about. Okay, so NASA actually was very favorably inclined to do that experiment, and the factor was that they moved this ATS-6 satellite all the way to cover India. For a year, they loaned that satellite to us. And we did all the other stuff that was associated with that, the ground segment, the TV for the rural setups, including the antennas that receive the television. And we had also the social groups that looked at the education framework and how do you look at people who are not formally educated, what kinds of programs were to be carried out. So it was one of those, when I first joined ISRO, that was one of the big things that was happening, and we were all very excited. So we saw in that a possible transformation of the education sector, and especially in terms of the people in the rural areas having access to the best kind of knowledge if it's possible. So this was a great view of the world at that time. And so I think one aspect of using satellites, using space, came into being around the time of Sarabhai's 68, 69 kind of framework. And we had a team from ISRO that was actually sent to Lincoln Labs in the US. And they came up with the notion of how to build a satellite, right, for meeting Indian communications and TV needs. So a lot of that stuff happened at that time. And I think SITE itself happened around 74, 75. Okay, so 75 is what I remember. So for 1 year, we actually did this experiment, and we developed the software. We actually had a team evaluating the results. Okay, so SITE was, in my opinion, a landmark, and we all thought, when I joined ISRO, we were all motivated significantly by the fact that we were really going to change India.
Just for the listeners, SITE is a satellite instructional television experiment, where ISRO used a NASA satellite to essentially build TVs.
Beam educational satellite programs to rural communities I think we had 3 or 4 clusters in India.
Yeah, and it covered about how many thousand villages?
Maybe more than that, maybe 2,500.
Yeah, 2,500 villages. And it's supposed to be also probably one of the world's largest...
It was at that time the world's largest experiment of that kind.
Yeah, okay. I remember reading about it, and I guess that laid the foundation to much of the investment.
And also the notion of INSAT, the need to build a satellite to replace that satellite. And the fact that, we needed to take space capabilities to actual people. So the applications actually grew. By the time that Sarabhai left ISRO, he died in 71. I think more or less this kind of approach had kind of taken place. I think even SLV was on the cards, the rocket part of it. Okay. And most of it in that sense, the rocket part as well as the satellite part and the applications part were all getting formulated, although at different levels. So applications obviously were immediately relevant. So obviously they were the drivers at that time. Yeah.
So when you come to the 70s in India in space, I guess we had moved from doing sort of sounding rockets and doing space science experiments to seriously considering more of the applications, parts and so on. But of course, India did not have satellite building capabilities of its own, possibly in the 70s. Can you tell us a bit about how this process or even the know-how of building satellites came into India?
Well, I think we were negotiating with a lot of countries at that time. Sarabhai was very well connected. Okay. And so for example, if you remember, TERLS is a UN-based, rocket launching center. We had collaborations with the US, with Europe, with France especially, and also with Russia, Soviet Union at that time. Okay. So TERLS is like a, acceptable place where all these different entities during the Cold War, right, could actually get together and work without some kind of problem. So we had all these very good. Japan also, we were very, very well connected with Japan too at that time. So one of the things that I think triggered all this was the possibility that at a higher level, the possibility of increased collaboration with the Soviet Union. Okay, so that came up in some forum. And I think the opportunity, I think the Soviets may have made an offer, okay, in a sense, because they saw a lot of potential. I don't know whether you know, every Wednesday in Tumba, right, a Soviet rocket used to be launched for weather. Okay, so there was a collaborative history of sounding rockets and all that. So, and I think there's also this political aspect of the Cold War and, the competition between the US and, USSR at that time. And so maybe the USSR thought it would be a good political move also. Maybe whatever be the reasons, there was this possibility that they would be able to launch a satellite for us. Okay. So I still remember, I was not involved directly, but I remember talking to a lot of people who have been involved in that. Mm-hmm. So there was this meeting in Delhi and this possibility came up. And I think Professor Rao, who was the director of the satellite center at that time, was identified from the ISRO side as a person. So we had this very interesting possibility that we could do this launch. And so we accepted that. So the idea was that we would build a satellite with some help from the Soviet Union, and then they would launch it for us. Okay. So that was how Aryabhatta came into being, right? So this must have been just around the time of Sarabhai's death, 71, 72. Yeah.
These are more the IRS or the remote sensing satellites or the smaller satellites?
No, Aryabhatta was not exactly a small satellite. It was not a remote sensing satellite. It was a simple, straightforward scientific satellite. It had 3 or 4 scientific payloads. The idea was not so much the science behind it, although scientists, of course, put, what I would think meaningful payloads into the thing. So we had a strong license with TIFR, PRL. They were our space-related scientists. So there was a package from both of them, right? And so it was put together. But the idea was not so much to do the application, the science part, as to be able to build the totality of the satellite, put it into orbit, be able to operate it successfully. Okay. And at weight fair, it was quite heavy. It was not a small satellite. Okay.
I was also wanting to know about how India acquired the knowledge of building the heavier communication satellites, because more or less the larger telecommunication satellites weigh a lot more than these kind of satellites.
So Aryabhatta was the first satellite that we built, okay, and it was a relatively primitive satellite, okay, if you can argue at that time. It was not so primitive when you look at other satellites of that time, okay, but it was still quite far behind, okay. So from Aryabhatta, so question is, once we had done it and we had put together a satellite capability, which functioned reasonably well. I think the payloads didn't work very well when we went into orbit. We had a lot of problems in that time, but you were still able to put it, you were able to get the telemetry from it, you were able to understand it, you were able to command it to varying degrees. It was a reasonably engineered, holistic kind of capability that we had built. The question then was, what kinds of things do we do, right? And what kinds of applications should we push? Okay, so this is a time when I would argue that the application direction was kind of important. So one possibility was to go whole hog into a completely INSAT kind of system. Now, if you want to go from an Aryabhat satellite directly to an INSAT kind of system, I think it would be quite a major leap forward for ISRO. So the other possibility was to do something in the remote sensing area, right? So these two possibilities were looked at, right? And if you go back and look at the Soviet capabilities, the Soviets were not necessarily involved very much in the geostationary part of communication. They had a very different system for doing the communication thing. It suited their country at that time. So there was this debate going on as to what kind of focus should we do. Okay. So one aspect that came up is that the Aryabhatta capability that we had built up could be modified a little bit, and we could put a simple television camera that would provide us some kind of a picture, very crude picture of the Indian, landmass at that time. So I think so amongst the two options, this one was the one that looked technically a little bit more feasible. Let me repeat again, you had many choices, technical choices, and the choices at that time seemed to be, it's easier for us to do the extension of the Aryabhatta capability to something we thought was an intermediate remote sensing capability. So the concept of a Bhaskara satellite came out of the Aryabhatta effort. It actually predated it a little bit, because once we were close to launching it, Professor Dhawan was interested to see what we could do with, what we should do next. So that option, therefore, was the one that we pushed initially. Okay. So we added a couple of TV cameras, changed the control logic because satellite control had to be changed. And we brought in a microwave capability because these were the two choices. One is a microwave kind of synthetic aperture radar, right? So we needed an input into the radio wave spectrum of the thing. So these were the two payloads that we chose for that, and we obviously wanted to build them in the country. So this was the concept of the Bhaskara satellite, which seemed to be a logical evolution of what we had done as far as the Aryabhat was concerned. In parallel, we were doing a lot of studies on what we should do on the INSAT side, or the equivalent of the geostationary communication satellite. Okay. For that, we needed another opportunity. Okay. And that opportunity came when the European Space Agency was developing the Ariane rocket, the first of the Ariane rockets. So they invited proposals for a passenger on the first or the second launch. I don't remember which one it was. Okay. So they wanted somebody to build a satellite that could go to geostationary orbit, right, using their launch. So that opportunity had to wait till the ESA thing happened, which happened around, I would argue, maybe it was around 82. So it must have happened in the middle 70s, I would argue, right. So that was the opportunity we used to go for the communication part. So this was the plan then. Okay, so we had Aryabhatta, Bhaskara, one part, and we had to do the site experiment. We had another experiment with the Europeans called Symphony, which used the Symphony satellite of theirs to do experiments. So you must remember that a lot of the user agencies with respect to INSAT did not want communication satellites. I think I have seen a letter from the Secretary of the Communications Ministry to the chairman of ISRO saying that they didn't see any need for a communication satellite. Okay. So we had to actually work with them in order to turn them around. So these experiments, including SITE and Symphony and all the Bhaskara, we did a lot of ground experiments with user agencies on the Bhaskara program. It was basically to create an awareness and a capability within the various user arms of the government in order to justify the logic of the application program we had planned. Yeah.
And a very interesting evolution, because I think this story is kind of very unique to India for any developing country. So with all of these moving pieces at the same time, at what point of time did the initiative to work with the industry or even develop an industry come into force?
As far as I can see, I only worked with Professor Dhawan. Okay, I joined ISRO in 74. Okay, Professor Dhawan became chairman maybe in 72 or 73. Okay, and I think from beginning, right, SLV, for example, the first rocket, first launcher that we built had very extensive industrial connections. Okay. It's simply because whenever, the policy was that if we could ever get industry to work, right, on what we needed, we must kind of do it with industry. This was clearly a Dhawan-driven initiative. He had this view that along with the space capabilities, we needed to create a viable, independent space industry. So, as far as I can remember, this was like an axiom, right? We believed in it. And we tried to make it happen as much as possible. There is also a lot of internal pressure within ISRO to build it in-house. Okay, and so there was always this dilemma between make yourself and go out and get it built. And I think we did most of the things we did at that time. I think were right. So we went, if at all anything could be done in industry, we would try and go and get it done in industry. So that was a kind of policy that we kind of followed. I think we were one of the people who pushed HAL. We have a lot of people in the private sector who contributed a lot to the SLV, all the big engineering things that we had in SLV. So we actually, I would argue that industrial development and industrial, in a sense, you can argue creating a space industry was a clear vision that Dhawan had. He always, and whenever he could, he would try to make sure that that part of it was followed. Okay, not only in letter but in spirit. Many of our engineers have spent a lot of time developing capabilities in industry. Okay.
One of the interesting bits that I see when I compare the Indian space industry as to where it is against many of the Western counterparts, or even the other ecosystems like Russia or China, is that some of the industry, although it's been participating in the space program for maybe 30 or 40 years and so on, their role has been more or less the same, in a sense that they've been doing incremental things and so on. But then, unfortunately, in India, we have not seen complete end-to-end manufacturer come into force from the industry, who could also take the IP that is created in India, the capabilities that we have, and potentially address several other developing countries and their satellite needs and so on. So even though we've spent more or less 50 years now in having the industry work with ISRO, we haven't seen this evolve over 50 years. So what is the potential reason?
I think as organizations evolve, they become successful, right? Success also requires a transition from what I would call an entrepreneurial kind of organization into a more routine kind of organization, right? So I think ISRO, in my opinion, till about the middle 80s, maybe, right, was able to build this hybrid capability where we were both entrepreneurial, right, and original, and, trying to respond to opportunities and, and problems that we faced at that time, right? As well as being able to do projects which required a lot of routine practices, which are fairly standardized, but which are also equally important. So we were able to do this hybrid kind of model. Okay. Now, the moment we became very successful, and the moment we became what I would call scalable, right, we tended to become more routine, right? Tended to become more rigid, and tended to be less risk. We didn't want to take as many risks as possible, because you had this whole what I call capability that we have a brand to satisfy. We have this image that we have to live up to. So you have this dilemma, and I tend to believe that a lot of people who followed maybe the first 2 or 3 chairmen have gone, into, trying to be less risk averse, pushing the routine part, which is important. Okay, no doubt about it. We need to do things well. But somewhere down the line, we seem to have missed the bus about the larger picture. Or what is the purpose, what is the logic of the space program, and how is it related to this country called India? And what kinds of things should the space program enable? So we had this problem that this aspect of it is maybe one of the reasons why we haven't gone and created an independent industrial capability that does all this. So I would argue that it's largely a creation of the fact that ISRO has been successful and it's continued to be allowed to do exactly what it wants to do. Right?
So is this also in a sense that the charter for technology is available with ISRO for several years? I've seen a lot of literature that says, for example, on space transportation that ISRO will be doing, like satellite launch vehicle, and then the polar satellite launch vehicle, and then the geostationary satellite launch vehicle, and then the reusable launch vehicle, and so on. But then there is no such longer term leadership on frameworks that will allow export of Indian space technology or export of Indian space products, in a sense that as a larger strategy to exporting India's space products.
See, to commercialize it, Professor Dhawan had a very clear idea. To commercialize, we set up a group that did a lot of this commercialization. I have a friend of mine, Sudarshan, who pioneered a lot of that. Okay, another friend of mine called Siddhartha, who also did a hell of a lot of work on all this. And Professor Dhawan had this view that industry was important. So in the 70s and maybe even up to the early 80s, we were very good on that industrial front. A lot of the propellants we needed to make, all the solid rocket stuff that we had to do, right? A lot of the satellite structural parts and, many things that we could farm out to industry, we did that. Okay. So it is my point would be that we did believe that it was a kind of mandate that we should follow that. Okay. And I think whatever we did at that time has kind of stood the test of time. All of that I tend to believe is still ISRO does it pretty well, and I think that part is there. There was a stage, in my opinion, around the late 80s when the INSAT system had kind of gotten streamlined, or maybe early 90s, I would argue, right? Where we could have actually transferred a lot of the stuff to industry, okay, which is what we should have done. But somehow it never happened, and I think it's largely because of the fact that, ISRO's mandate, right? Nobody actually ever questioned its own definition of its own mandate, right? And India, since there are so few success stories, you don't want to touch a success story, right? You don't want to meddle with it, right? I mean, that's one of the reasons why I think this did not happen.
From when you look at other ecosystems, let's say the US ecosystem or the European ecosystem, I find that a lot of the industry there, for example, evolved because of the state support for risk taking. So I know that, for example, let's say if the US industry in communications, for example, they wanted to lease out some transponders so that the risk is reduced, or even in case of imaging satellites, they went and procured some of the capacity of the imaging satellites so that the industry benefits having a customer ahead of launching a satellite and so on. So there were a lot of these kind of policy innovations in some form or the other. And at some point of time, the policymakers in the US drew a very clear line as to what NASA can do as a space agency and what is the mandate of the industry. In India, we have had both of them, not defined, in a sense that there is no policy prerogative of either supporting the industry actively to mature this industry into a more evolved one, or there's also not a very clear line as to what is the role of a research agency as well as what is the role of a production-oriented, direct market-driven industry.
I agree with you to a large extent. Okay?
Yeah.
I agree with you, except there are some variations. A little bit of nuance is maybe useful. A lot of what you said was the original purpose of a lot of what we did. We created a lot of this industry interface. What is Antrix Corporation? We had the nucleus of it even earlier. and a lot of the export aspect of it and a lot of the development. And we've actually gone and contracted with a lot of these guys, especially on the application side, for many internal needs also in that time. We give them a guaranteed offtake. Unfortunately, what has happened is, I think in the transition period, when we move from this hybrid model, right, into the operational model, a lot of this should have happened. Okay, and it has never happened. A lot of that reason, I tend to believe, is simply because of two factors, I would argue. One is the inability of anybody from the top telling the system that, you need to make these changes, right? Industry in India, historically, has never been very pro-risk, okay? So we've never had any great pressure from industry, except to take into account things that are needed to be done. So there is no industry pressure on the political system, for example, for change. It's not there. So this leaves only one option, that is the ISRO system or the government system, through application of pressure on ISRO, should actually change. Now, these circumstances, people don't know, in my opinion, about these kinds of approaches and what space can actually do. There is a paucity of knowledge in all kinds of policy making and decision making circles about this approach to development. Now, while economists have looked at other industries very well, and space is not seen exactly in that model. For example, in energy systems, there is some attempt at pushing the industrial thing. I'm sure you can look at a whole lot of other industries and see these trends happening. They're not happening in space. So one part definitely has to do with the internal ISRO, what I call dilemmas on how to proceed. And the other part has to do with there is very little pressure on ISRO for change, right? And ISRO, of course, controls the entire space value chain. So it's a kind of monopoly, right? So you have an asymmetric situation where people don't know what can happen. On the other side, you have this monopoly which is going to resist.
Yeah, because I think several of the sectors in India, like space or defense or any other sectors which are heavy technology driven, I think the institutions or even the government never looked at them as an opportunity to create an industry, or looked at it from a perspective of contributing to the economy rather than establishing.
This is ironical because according to me, the entire program, justification of the program, is actually on social grounds or on economic grounds, irrespective of whether you're doing it for money or not doing it for money. Clearly, there's a lot of value addition that is going to come. And a lot of that value addition cannot be done by one entity. It has to be done by several entities, right? Both the IRS program and the INSAT program were the first programs in the country to involve user ministries, right? I mean, IRS, for example, we've spent a lot of time, selling IRS to all user ministries. I think Professor Dhawan must have made about, 30 or 40 presentations to Delhi to all kinds of people, right? Trying to tell them what we can do. And we had this user interface and IRS program. We had this INSAT, user group, right, which actually created the kind of thing. But if you look at all of them, they've all been hijacked in a sense, right? The original purpose was actually to promote it, right? They've all been hijacked into fairly narrow, right, what I would call ISRO-driven, right, rather than country-driven. And that is really because I feel people really don't know what the implications are.
Just for the listeners to clarify, IRS is the Indian Remote Sensing Satellite System that involves satellites that are collecting images over India or other sensors. And the INSAT is the Indian National Satellite System, which is mostly communication satellites. Again, from a user's perspective, a lot of the services in India over a period of time evolved as government-to-government services, where space was a product which other ministries or other departments in the government of India could use. But of course, technology and the proliferation of technology changes in the society and so on. But today, for example, what was supposed to be government-to-government services could also be addressed as government-to-citizen directly services. So one of the examples of this is the application developed for, let's say, the fishermen, where in the early 90s or the end 90s, ISRO collected sea surface temperature and chlorophyll content to basically point out where the fish is so that the smaller fishermen could go directly collect the fish from there. And, I saw a paper, for example, that said, okay, this increased the catch of fish by more than 50% and saved some 30 or 40% in fuel. And, that added up to 5 or 6 lakhs of income for the fishermen over a year or something like this. And during this time, I saw that the technology was developed, but then when the information had to be passed on to the fishermen, there was no network layer, so it had to be faxed to the Fisheries Survey of India, and then they had to in turn give it to the fishermen and so on. But then, that also evolved to then internet being used as a medium to transport this information. But with all of this, the user application from a user's perspective, the information, could be widespread even more. Today, when, for example, a smartphone could be used directly to provide the service, directly to the citizen himself, right? Why do we not see this kind of architecting today change?
I think it's a big opportunity space. Yeah. I think today the situation is very different. I think in my time, for example, I think there were structural problems associated with availability of information and data. Today there are multiple sources. Even if Indian government or the Indian satellites are not available, data is available somewhere, right? And it's a huge opportunity space to take a particular application, be able to put together an architecture that involves a significant space component, but other components as well. And in my opinion, there is an opportunity to make money. I think it's not a bad thing. And this is not against the social vision of either Sarabhai or Dhawan. I think they didn't think it was anything wrong to do any of this. And so my point is, I think this is only one part. I think there are zillions of data applications, right, where this can be done. I mean, weather is one, agriculture is huge in India. You can look at urban problems of all kinds and you can come up with many, many possible uses of satellite technology. GPS and navigation is another huge area where many opportunities can be exercised. There's a lot of work on precision agriculture, which again, high value crops, for example. India has got a very big agricultural sector. Sugarcane is big, cotton is big, cereals are huge, fruits and vegetables are big. So, I mean, India is potentially a very, very big agricultural country. Right? And a lot of these applications are possible. Today, the supply of data is not a problem. The ability to connect up the different components that create value and provide that value in a form that a user can use is the challenge. I think it's a huge, huge space.
Can you tell us a bit about what were some of the earliest pioneering socioeconomic benefits that came out of sending these imaging satellites?
See, one of the things that we did in a study for ISRO, after I left ISRO, we did a study. So one of the things that looked very, very possible at that time was, if you look at sugarcane is a big industry in India. And if you can estimate the condition of the crop, now this partly can be done from space, but you need a lot of ground-based information also. So in that study, which we did about maybe 15 years ago, there was this company, sugar company, that was actually buying IRS images. And they were trying to assess the condition of the crops around that region. Now, sugarcane had a lot of restrictions in those days, you must remember. A sugar mill had to buy sugarcane only from the surrounding area. I think today maybe all those things are removed. So you need to assess the condition of the crop and make sure that you cut the crop at the right time. If you're able to do that and you're able to take that supply and push it into the mill, I think the yield numbers that you get will be, they will differ from the normal yield by about 1 or 2 percentage points. That makes a significant impact on the economics of the sugar industry. So we did a fairly detailed assessment of this. So the other thing that I remember doing was to look at the cotton. Cotton is again it's a cash crop. And it's a very controlled crop. It's got all kinds of problems associated with that. And by simply looking at allowing trade in cotton, knowing, for example, the supply side of the problem and the demand side of the problem, which seems to be available, not too difficult to estimate, you could actually manage the crop better. So what happened very often is that the import decision would happen after, first there would be this fear normally created by vested interests saying there's going to be a shortfall. So which will say that you please go and import. So the government machinery to go and import will take some time, right? So imports will come. But by that time, they will find out that the actual crop is significantly more. So people, so you have one vested interest which is interested in high prices. So the prices rise. Then after that, there's a steep fall. The same vested interests are able to make use of the fall in order to... So you had this absolute mess. And then you had the subsidy component coming in. So you had a standard price. So Cotton Corporation of India, which was supposed to do that, for example, at that time was making a lot of losses simply because of being able to manage. So all the stuff that was there can actually be eased if you had a space-based system. Now this does not mean that there are no ground-based components either, but with a space-based understanding of what the crop is, you can significantly put together an architecture that delivers actual value. What is the value of information if it is not used in making a decision that has value? So the problem in India is all these regulatory mechanisms, the value chain itself, the decision making. So by the time it reaches the user, who's a cotton farmer or, a cotton mill, for example, would like to buy and sell, right? It doesn't want a huge stock unnecessarily, right? So we did an assessment of all the value that you can accrue. It's a substantial amount. I'm just giving you two. There could be many others, right?
So interestingly, in your career, you moved from space into management studies. And I think, as I said before, you probably are the only person that I know in India who comes from a space background and then moved into management studies, where you also studied from a strategy perspective a lot of the space program and so on. So the question is, why don't we see more such social scientists or even management researchers getting involved in doing an analysis, a cost-benefit analysis, or even a social analysis of how space is creating or solving a lot of problems?
See, I have a weird background. Okay, I had a degree in engineering from IIT Madras. At that time, there were no engineering jobs around. Okay, so all of us had only two choices: either go to the US or go and do a management degree and sell soap. This is normally the kind of career that many of us had, or possibilities at that time. So when I graduated, for example, I decided that I didn't have the option of going abroad. I had other constraints on the domestic side, so I decided to go to management. So I went and did this great degree in IIM Calcutta, where I got my... So what happened is, after that, I was fortunate. I think I was fortunate to pick, ISRO came on to campus too. So I think Sarabhai and Dhawan had this view that they wanted some inputs on the side that was not so technology dependent. So I, along with a few others, we were about, I think we might have been about 10 to 15 MBAs in ISRO all over. And I was fortunate to join the group in headquarters because, I worked directly with Professor Dhawan at that time. But we were all kind of selected with the idea that this social aspect, this economic aspect, this industry part of it should not be completely forgotten in this obsession with technology and technological capabilities. So it was a kind of unusual combination. So I actually had this technology management background, which normally I would have gone into, in those days, TAS was a great Tata Administrative Service, or a career in Hindustan Lever in marketing. These were or World Bank. So when I joined ISRO, for example, I had this clear idea. I'm going to spend 2 years here, right? And then I'm going to leave India and go and join the World Bank. At that time, World Bank was considered to be one of the great privileged jobs for MBAs. So it so happened that, you got sucked into this. It's such an interesting part, For me, it was fascinating, right? And space is really, in a sense, something that, I don't know, it kind of appealed to me a lot, and I got very involved in the program. Maybe too involved, that's the other part of the part. Get too involved in the program, and therefore you have all this. And ISRO was a great learning opportunity space. Professor Dhawan, great man, absolutely out of the world. I had a bunch of colleagues who were fantastic. Each of them had their own kind of problems, but together as a team, we were really very good. And I think at that time in India, possibly we had the best collection of talent, either in the public or private sector. We were really fortunate. But it was what I would call a golden period. Till the hybrid farm flourished, we were all doing okay. The moment we got into the operational part, I think we found ourselves largely out of place, right? So that's the kind of thing that happened. So it's not true to say I did have a management pedigree, but I learned maybe a lot of technology. There was a time when people used to ask me about optics, the IRS cameras, for example. I used to be very knowledgeable. I used to be very good in orbit aspects of mission management and all that. So I learned a lot of stuff. Rocketry, stuff that is. So you have this hybrid. So when I went to IIM, the other part of it is, you had a lot of background in the space part. So you went and revisited management in a different way. So you had this hybrid. Again, I'm sorry to use the word hybrid, but you had this combination that was quite useful. All right. And of course, space technology is only one technology, right? Technological patterns and how technology affects change and how it is affected by social forces, for example, is something that is worth on its own, right, a great deal of. It's intellectually very stimulating, it's academically relevant, and I would argue it's personally very interesting. And I think all the areas of interest is one of the problems of domain in India and academics in India. It's all focused. And you're looking at all this pressure to publish. I didn't publish any great papers when I was working in ISRO, right? After I went to IIM, you started publishing a few. But in those days, we were invited to write papers in the most prestigious journals, right? For example, I remember writing some paper on peaceful uses of space. Right, so I used to represent India in the Outer Space Committee. That's part of my job. So you also learned about the politics, the geopolitics of space. So it was a fantastic kind of place to work.
India recently announced the human spaceflight program, and of course, Sarabhai had a vision. He famously said that, we don't have the fantasy of competing with the economically advanced nations and, entering into human spaceflight. But India has now, announced the human spaceflight. Is this a corrosion of Sarabhai's vision, or?
I would argue yes. Professor Dhawan was also very, very clearly opposed to it. And I remember the Soviet offer for a manned space mission, and ISRO had the choice at that time of becoming a major player in the manned mission. Professor Dhawan didn't want it. Okay, he felt it would come in the way of the more higher priority programs that we had to do. Okay. I think both Sarabhai was clearly very much both of them were clearly very much against it. I think subsequent chairman may have had mixed thoughts about it, but there was always this belief in ISRO that we had to do something that was socially and economically relevant. Yeah, that was one of the major underpinnings of what we had to do. But having succeeded, as I said, and having done a lot of the routine stuff that we have been doing, I think the problem today for ISRO is what do we do with all that capability and what kinds of things can we do with that? There are two clear things that are there. I think the world political system has changed. We lived in a sanctuary regime of space, where, the bipolar world was a stable world. And we looked largely at peaceful space. Okay, there was no word. So one problem today is that that world is gone. It's destroyed. And today space is not only militarized, it's weaponized to a larger extent than it ever was. And I think the trend is going to be that is going to continue to happen. So that is not a problem. The point for ISRO or for the Indian space effort is, what do we do with that capability and what kind of focus should we look upon? So one part is political prestige kind of programs, right? The other part, in my opinion, is continuing to do the economic relevance and spin it off and create a viable industry, maybe create an industry itself that can independently do a lot of that. While ISRO does the, cutting edge work on technology and, missions. The third possibility is the manned program, right? Which gives a lot of political prestige. I tend to believe that the political aspect of it is, I think we are looking at China and what it is doing. We're looking at competition. We are looking at our image in the world. And therefore, the political part seems to have won. I think the military part will suffer. because I think that's a more important area where we have not put in enough work.
Can you share a couple of anecdotes maybe from your days which were probably like bizarre, because most space programs have bizarre superstitions as well as bizarre happenings?
So, for example, one of the things that I remember very much is how did India actually ratify the Outer Space Treaty? Okay, I mean, I was directly involved, so I thought I would give you my take on it. Now, we were a part of the political process that came up with the Outer Space Treaty. India has been a member of the Outer Space Committee from day one. Okay, so we signed the treaty when it was cleared for signature in 1967. When I joined ISRO, Professor Dhawan was seriously looking at a lot of this stuff, and he wanted us to kind of do the right thing. Right? At that time, we were looking at a sanctuary regime. Right? We were not looking at a lot of this stuff. So he wanted India as a potential emergent space player to be part of a system that conformed to certain, international norms. So he wanted us to ratify that treaty. So we spent a lot of time. I mean, I must have generated, along with him, a lot. We had about 4 huge files of paper. So we wrote to all the relevant agencies saying that now that we have these nascent capabilities, we are likely to become more important. We are launching these satellites, right? We have to conform to what is common practice, what is common international norm, etc. and all that. We generated a lot of paper. I think every time Professor Dhawan went to Delhi, he would meet somebody, right? And, so this thing kept on going for about 3-4 years. Now, parallelly, we were also committed on the second United Nations conference was getting organized. And I think Professor Yashpal, our director from SAC, was selected as the first chairman of that conference. So Professor Dhawan felt at that time that before the conference, at least, we must get this thing done. Okay, but nothing seemed to work, nothing more. Then suddenly what happened is there was this laboratory that NASA had put into orbit called Space Lab. It got into some problem. Immediately after launch, it had some problems. So it was planning to re-enter. Okay. So NASA had put out the circular saying that India is likely to get hit. There's a high probability that India may be suffering from falling debris from that re-entry. And it kind of issued a warning to everybody. Now, this suddenly created a turmoil in the government. Okay. And I remember we were making a presentation on that NewSpace conference in Delhi to people to finalize the Indian position. So at that time, this matter came up for discussion. And suddenly the government realized that we are not party to any of the treaties on outer space, and we could be. And therefore, if something landed on India, we were in a legal position where we might not be in a position to take any action. So overnight, there was suddenly a pressure for us to sign and ratify the treaty. So I think within 2 or 3 days, the External Affairs Ministry moved a couple of things, and then we ratified the Outer Space Treaty and the Liability Convention. I mean, that was... So you had a lot of effort going on, right? And finally, some trigger outside that kind of enables us to happen. That was one, I think, which I remember as something unique. The other thing is we had a lot of negotiations with the Russians. And there were a couple of interesting anecdotes that I think are useful. Now, we had negotiated and I was involved directly in the launch. We were the first country in the world to commercially source a launch from the Soviet Union. Okay, IRS-1A was launched by the Soviet Union. It was a commercial contract. Professor Dhawan said, we've got enough free things from them. We must go and do a commercial launch. So we had a long negotiation with them. So one of the things that came up in those there were 2 things actually. One of them was the notion of a launch window. Now, when we do any launch services negotiation with the US, for example, you have a notion of a launch window. You say you have to launch an IRS satellite between 10 o'clock and 10 or something like that, right? So one of the questions we asked the Soviet Union at that time was, we need to launch it at this time. So we need to know what is the variation in time between them. So those people were very clear. They said, we don't have launch window. If you say 10 o'clock, we will launch at 10 o'clock. Okay. Which I thought, for a guy like me who was involved in all this American thing, it was such a robust and such a, what I would call. So you would see suddenly the rocket come there, and next it'll always, snowstorm, anything, they would be able to launch. A very robust program. And in a sense, you could argue very, very reliable program. So that was one. The other thing that came up was launch insurance. We had this negotiation in the INSAT, where if you launch it on a NASA rocket or on a US rocket, you are worried about liability insurance if the rocket malfunctions and it creates damage. So NASA's approach would be you take launch insurance. You go to a commercial insurer and take launch insurance against that. So that's a standard approach. So I remember the number used to be around $200,000 or $300,000. A lot of money in those days. So that used to be the launch insurance. So when we negotiated with the Soviet Union, so we had also this INSAT lobby, which was part of the negotiating team, who said, we must worry about launch insurance. So I was one of the guys who said, I think we should not raise this issue like this. So we had an internal debate, and I think finally Professor Dhawan reconciled it by saying, we can use it if required, but let's first find out what is their procedure to deal with such problems. So the Soviet Union guys said, launch problem, we don't have any launch problem. If anything happens inside Soviet territory, right, we'll have nothing will happen outside Soviet territory. Okay, he also said that very clearly. So he said, launch insurance, he said, if in spite of it there's any problem, we will give you another free launch. Okay. So he said, the entire deal was such that they went strictly by the international thing, which means that liability part, the liability for the launching state and the liability for us is resolved mutually in this way. Okay. So, it was one of those things where I think we saved money without having to tell them exactly what we should do. There were a number of other things that one can talk about, but I think a lot of it is, I don't know. In IRS, for example, we had a lot of problems immediately after launch. So how we resolved them and, what kinds of... We had some very phenomenal technical capability in that time. I'm sure today also our engineers are damn good. They're very good.
So thank you very much for taking time to speaking with me.
It's been a pleasure.
Thank you for staying until the end. If you have any comments or suggestions, please write to curator@newspaceindia.com. Please use the link in the description if you want to join the NewSpace India community, and have a great day or a lovely evening depending on wherever you're listening from.